people aged 90 and above are considered centenarians among the Earth's population. There aren't many of them, yet some have lived a full century and witnessed a great deal. Human civilization is somewhat similar to the universe. There are very young planets, barely formed, absorbing the rays of their parent star like a child feeding from its mother. There are older planets, adult, mature, having orbited their star hundreds of times. And then there are truly ancient planets, the long-livers. Their age is measured in billions of years. In the constellation Scorpius, 12,400 light-years from Earth, lies one of the oldest known exoplanets, Pulsar 1620 to 26b, or the Methuselah planet. Methuselah's ancient history and peculiar home. According to the Big Bang Theory, the universe originated approximately 14 billion years ago. The exoplanet Methuselah formed in the globular cluster M4 about 12 billion years ago. Imagine this planet appeared at a time when Earth and even the solar system essentially didn't exist yet. Methuselah's mass is 2.5 times greater than Jupiter's. It resides in an unusual binary system, both components of which are burnt-out stars that have long completed their active evolutionary phase. A millisecond pulsar and a white dwarf. It orbits these stars at a distance of 23 Australian dollars, slightly more than the distance from Uranus to the Sun, completing one orbit in roughly 100 years. Methuselah has a turbulent and unusual history. The white dwarf in this system is 331 times less luminous than the Sun. In Methuselah's sky, this star would shine only slightly brighter than a full moon and appear as a bright, bluish-white star. If not for the second star, the pulsar Methuselah would be plunged into eternal night. The millisecond pulsar itself is a very old neutron star, vigorously spun up by the accretion of matter from a companion star. The white dwarf is the remnant of that star. The accretion process ended about 480 million years ago, and now the pulsar's luminosity is comparatively low. But rather, it's low compared to other pulsars, because compared to the white dwarf's luminosity, it's immense. Chemical composition and extreme environment. The chemical composition of the stars in the system also differs from the Sun's. Since these are very ancient stars, they contain approximately 20 times fewer heavy elements than the Sun. Most likely, Methuselah's chemical composition is also depleted, meaning it consists almost entirely of hydrogen and helium. Due to the orbital plane's inclination at a 55-degree angle, Methuselah is irradiated by the white dwarf for most of the time. But twice during its orbital period, or more simply every 50 years, where its orbital plane intersects the pulsar's emission plane, it gets hit by a furious pulsar beam. A pulsating stream of electrons and positrons, along with hard X-ray radiation from the pulsar, rains down on the planet's upper atmosphere. What is the planet's average temperature over an orbital period? It's approximately -145 ring operator C. However, this doesn't account for internal heat sources, which may have already depleted over 12 billion years. If some of the energy is not absorbed but scattered, the average temperature would be slightly lower, but it can't be too low either. Methuselah is in a globular cluster, and the cumulative radiation from the cluster's stars heats its atmosphere. For most of its year, Methuselah is heated by the white dwarf's radiation, the cumulative radiation from M4 stars, and has a temperature of approximately -193 ring operator C. At such a temperature, Methuselah would be enveloped in light, dark blue clouds of frozen methane. Most likely, Methuselah is a gas giant without a solid surface like Earth. Its deep blue color and light clouds are somewhat reminiscent of Neptune, aren't they? Measuring distant temperatures and ancient stars. By the way, I recently read comments and realized that many are quite skeptical about temperature calculations. They wonder how scientists can calculate the temperature of a planet that is incredibly far away and where nothing but a blurry spot is visible. Well, the temperature of distant stars, planets, and other celestial bodies and objects can be measured by analyzing the spectrum of their radiation. In simpler terms, a star's color directly depends on its temperature. Color acts as an indicator while mass affects the temperature itself. Now, I have a small request for those who want to help and can explain to unaware and, consequently, disbelieving individuals that measuring the temperature of planets is not such a complicated, let alone fantastic process. I know you can do it more accessibly and elegantly than we can. Write in the comments. Let's share knowledge. Finally, continuing the theme of ancient objects, very recently, astronomers found one of the oldest stars in the Milky Way. The object J0815 plus 4729 came into being about 13.5 billion years ago, according to scientists. The discovered star is located 7,500 light-years from the scattered region of stellar dust, the halo of the Milky Way, and belongs to the class of dwarfs. Researchers report that the star contains minimal amounts of iron and calcium. At the same time, its composition has a high concentration of carbon, indicating the antiquity of the discovered star. Most of the chemical elements in star J0815 plus 4729 are light. Carbon and calcium are present. The element iron in J0815 plus 4729 is present in a very meager amount, about 1/1,000,000th of the amount found in our Sun. In such stars, all elements heavier than hydrogen and helium are only found if the star is very old, one of the first in the universe, and was affected by a supernova explosion that occurred nearby while the star was still forming. But although star J0815 plus 4729 is indeed one of the oldest in our galaxy, it has a competitor, star SMSS J0313-6708, which also has a similarly carbon-rich and metal-poor composition. The study of these rather rare stars will help shed light on the early chemical evolution of our galaxy, as well as the nature of the first stars in the Milky Way.